So in last lecture we discussed about, so I make quick review. Last two lectures we discussed about the motion in space in 3 dimension, in x and y and z, and we learned that if I want to describe any point in space, that means in 3 dimension, in x, y, z, that is x, that is y, that is z. So I pointing to this point with the polar coordinates r. After that I describe it in Cartesian coordinate with the points of x1, x2, y2, y1, z1. That means the point in x direction coordinate, the point in y coordinate, and the point in z coordinate. And we know how to describe it, and we know the r as a factor. It is the position of the factors, and r change with the time, so that is r of t, so that means the position factor with as a function with the time. And also we know how to find how to apply the kinematic equation to find the 5 important variables: v initial, v final, and acceleration, and t, and the distance or the displacement as a combination of the factor in space. So just only I have 3 important equation in kinematic equation: v final in x or in y or in space. How I can find it? V final is equal to v initial plus a t. Second equation, v final square is equal to v initial square plus a 2 a delta d, or I make it d as general, then d as distance equal to d initial plus vit plus half a t square. So these 3 equations we want to apply it and to find it in space, and we mention about it just only you put as factors. That means f final in the space in I and j and k, in x and in y and in z, v initial, a acceleration. So that is the equation. Here you change or replace delta d as a distance in x, and in y replace it with delta r as a position of the factor in space. Here also you replace it delta r equal to r initial plus vi t plus half a as a factor t squared. So that is the 3 equation, and we give one example, and inshallah I hope that I upload for you some problems and we discussed about it tomorrow inshallah in our lecture. Then we started to the second lecture. It's about the projectile motion. What is the mean of the projectile motion? It is the motion under the influence of the gravitation only. So the others, it will be neglected. The other variable or the other things that it will be effect to this projectile or to this motion, so it is neglected, so it equal to 0. Just only we can take the values under the gravitation only. So, and we discussed about the first part. It is the first part when I firing from 0 0, so that that means I starting firing or launching from the y is equal to 0, so that means from the origin points. And we find that in this position we find from the points, there is one point here, it is the maximum height. This one point here is a maximum height from 1 to 4, and we find this maximum height when Vy is equal to 0. Then there is another variables. It is about the time flight to reach this point and the time from this point to the ground. And there is also one point, it is from the start till reach the ground, it is a range. And we calculate all of this thing, just I make general review for it here. So all the works in vertical, and we know why it's in vertical, because the acceleration works, the gravitation works in vertical, but in horizontal there is no any force. And we put it in the table and we applied all this equation. So from these three equations in vertical, so I want in point 4. So in point 4, V final y is equal to 0. So that means h, I replace h to delta y, I replace it to h. أغير من delta y إلى h means the sample of the maximum height. So I start apply equation 2. Equation 2, V final y is equal to V initial sine, and from equation 1, the important equation, that is the y and x as a component, as a combination, and the value in x and value in y. So it equal to in x Vi, I write it here, in x, in horizontal Vi cosine theta I, in y it equal to Vi sine theta I. This is the important equation 1. So from equation 1 we know that is V initial, it's equal to Vi sine because it's in y, minus 2g delta y, I replaced delta y to h, so h is equal to V initial square sine squared theta over 2g. Now I want to find the time to flight from starting to the highest point. So from 1 to 4. So I know from equation 1 t is equal to, so in point 4, so the V final is equal to 0, V initial is equal to Vi sine theta over, move this to another side, then that is the equation. In simple cases, if it's not mentioned about the sine theta, or sometimes it's not mentioned about the initial, so I used the t square for special case is equal to 2h divided by g, that is from, and t is equal to square root of 2h divided by g. This you can prove it from equation 1 and equation 2. But I'm not want to confusing you, so just I give you the equation direct. Then we discussed about the time flight, and it's equal to 2t. Why it's equal to 2t? Because the from 0 0, from the origin, the shapes from the point of the highest, it's equal to each other, so identical or symmetric shape. So the time to flight to reach the highest is equal to the time from the highest to the ground, so it equal to t 2t, and that is the equation. I find t, just only added 2, that means the total time. The range, it is the distance between the start point till the end point, and we know in horizontal just only it's changing with the time, so x is equal to v initial cosine theta multiply t, and we know t, how much t, just replace t or give the value of t, it's 2t 2 vi sine theta, then the equation from mathematically it equal to r is equal to v initial square sine 2 theta divided by g. So in symmetric there is an important four variables: the range, how you can find the range; the maximum height, how you can find the maximum height; the time t1, it is a time to flight, the flight time to reach the maximum or from the maximum to the ground, anyone; and number 4 is the total time, it is the adding of the time to flight to reach then from the maximum when it's reach a maximum to the ground, so it's 2t is equal to 2t. So that is the important things, and please try to make some exercise to proving and to calculating in this equations by using this equation. Now today we start the last third lecture. It is the last lecture in this part. So when I firing from 0 from the origin, so it is symmetric, so that means t1 is equal to t2, so that means t total is equal to t. The other things that we mention about it, the maximum height, then the range, and also the time is equal to 2t total time. And the last point, as I mentioned it here, it is about the time to flight, that is t total, and t1 plus t2 t1, the time to flight to reach the maximum height. Here t2 from reach the maximum height to reach the ground. So that is the important notes in chapter in symmetric, when it's firing from the origin 0 0. Now when I firing or launching horizontal, what's the mean of horizontal or horizon? So that means in this position, so that means cosine and sine, the angle is 0 because it is horizon. So that means firing angle is equal to 0. So for cosine it equal to 1. So that means the equations it applied in horizontal, just only one equation, that is the equation of delta x. And here there is no range, because the range here is not same, it depends, because here I move or I starting from delta y, I am not starting from 0, I starting from top. So I have distance, this distance above the distance I firing, and I firing with angle. This angle at second part it is horizon, that means the angle is 0. So in horizontal the cosine 0 is equal to 1, so that means my equation it working, then there is no problem. So my two equations, number 1 and number 2. Here in vertical the equation working, but any angle with sine 0 is equal to 0, so that means v initial sine 0, v final sine it equal to 0. Anything with 0 with sine theta, so theta is equal to 0, so it removed to 0. So v final is equal to minus gt. V final from the second equation minus 2g delta y. Delta y is equal to minus half g t squared. And this equation, that is the equation that I mentioned to you in the last, so you can take it from here. So t squared is equal to 2 delta y divided by g. If it's in maximum height, just change this to h. So it is the same equation. So that is the important thing in chapter, in second part, when I firing from horizon. So when I firing from horizon, the important thing to know, that is the angle. Theta I is equal to 0. So be careful. Cosine 0 is equal to 1. Sine 0 is equal to 0. Apply it in the equations in x and in y, and you find in x you have the same equation, v initial is equal to v final. The delta x, the point from this point to this point, it equal to vi dot t, because cosine is equal to 0 is equal to 1. But in y, because sine 0 is equal to 0, so just only v final is equal to minus gt. V final square is equal to minus 2g delta y. Delta y is equal to minus half g t squared. Now there's the second position. When I firing above the horizon, so that is the horizon, so I firing above. So when it reach to this point, this is not maximum height, so be careful, because I starting firing from distance delta y. I am not starting from here, so that means this shapes is not symmetric, because this part is not equal to this part. So be careful. And the same equation, it will be applied. Just the angle here, 50, 60 degree. So you can take the degree, the angle, and calculate it in sine and in cosine. So it depends on the point position, and use the equations of the kinematic with the same equations. In x you have 2 equations, in y 5 equations, but adding for it here v initial, that means vi sine theta. Here also added the equation in completed sides. Last part, when I firing above the horizon, so that is the horizon, I firing, sorry, below, أقل, below. So my angle is here, beta. That is my angling fire, or theta I, and that is the angle, you know it. So how I know this angle? It's very easy. So make your coordinates. So that is the first quarter, second quarter, third quarter, so fourth quarter. So my beta is equal to 360 minus beta. I can find the firing angle that I wanted. So beta is not my firing angle. Beta the angle, and it's given in questions that for student using this angle, but it's not firing angle. In our question in physics, just we give you some angles, but be careful in the sentences of the questions. Beta always is not the angle of firing. The angle of firing, it is the angle between the V initial and the axis of the vertical. So be careful. الزاوية التي تكون زاوية الإطلاق هي ليست بيتا، وإنما الزاوية الأخرى. فكيف أجيب الزاوية الأخرى؟ بما أنه هذا في الربع الرابع، فأستقل البيتا. دائما في الفيزياء لازم المعطى يعطى لحاجة معينة، بس أحيانا بعض الطلاب يتلخبطوا يظن أن البيتا هي زاوية الإطلاق. لا، البيتا مش زاوية إطلاق، البيتا هي الزاوية المتممة. فكيف أجيبها؟ يا أما أجيبها بالتتميم أن هذه 90 درجة وأتممها، يا أما أن أجيبها من 360، بعدين في الربع الرابع أزود على المتبقي من 90، لأنه في الربع الرابع كوارتر 1 كوارتر 2 كوارتر 3 كوارتر 4. and always delta y is 0 because it's opposite، لأنه هو بيغلف إلى الأعلى فراح ينزل إلى الأسفل. and vy is also minus. So that is the three important position of the firing or launching the projectile and the motion of this projectile when it's firing. Number one, when I'm firing it from 0 0 from the origin point, so that means delta y is equal to 0. So I find that there is a maximum point, there is a range, there is a time to flight to reach the high, the maximum height, then the time to reach from the maximum height to the ground, and the shapes is symmetric, identical. So it's very easy, and I use the kinematic equation and find the value of the range and the highest point, the maximum point, and the time to flight and the time to reach the ground. Second part, when I firing horizontal or launching horizontal in this point, that means the angle of the firing is equal to 0. So that means cosine and sine use 0. Cosine 0 is equal to 1, sine 0 is equal to 0. So be careful when you apply your equations in cosine and sine with the angles. Third part, when I firing above the horizon, so it is a very normal thing. So you can use the angles that it given, use the initial velocity, but be careful, the maximum height here, it is different because the shapes is not in symmetric, and the time to flight is not equal to the time to reach the ground. The time flight to reach the point, the maximum point, is not the same time to reach the ground. And use your equations with just only change the value in questions, and I give you some questions and some practice problem. I upload it inshallah just a few minutes or half an hour. I upload some equations to discuss about it tomorrow. Last position, when you firing below the horizon, and the big problem here, that is the angle that I given alpha, beta, gamma. It is not the angle of the firing. The angle of the firing you can find it 360 degree because it's in quarter 4 minus the angle that it will be given, so it gives you the angle of the firing, and always delta y and vy minus because it is opposite to the position that I did. So I hope all things is clear. I give you some practice problem. We try to make some review, and inshallah I hope this chapter it will be covered, it will be clear, and inshallah we hope that in next week or in the end of this week we start our last chapter, chapter 5, the Newton's law and its applications. So thanks a lot, and see you in our lecture tomorrow inshallah. Bye.